Hi, so I'm going to start doing a couple of examples using combinations to calculate some probabilities. So this example says a package contains 12 resistors, 3 of which are defective. If 4 is selected, find the probability of getting our three parts. In the first one, we're going to find the probability of getting non-defective resistors. In the second part, exactly 1 defective. And in the third one, 3 defective. So when approaching these problems, I like to think about a very simple diagram just to keep things in our head clear. Is that I have my shipment, whatever you want to do, has 12, in this case, resistors. 3 are defective. That means that I'm going to split 3 defective, and there are 9 that are non-defective, right? So you're going to select 4 and find the probability of getting non-defective. So if I'm going to select 4 and they're all non-defective, that means I want to select them all from here, right? They're all going to be from the group of 9. So I'm going to find, it's a probability, so I'm going to divide total number of possible outcomes in the denominator, and in the numerator it's going to be the number of favorable outcomes. So what are the favorable outcomes in this case? It's going to be exactly when I get it no defective resistors. And in the denominator, I'm going to divide by, I'm selecting 4 and no restrictions, right? So in the past videos, we talked a little bit about this. So that denominator is going to become, I'm selecting 4 from the total, and that's exactly when you do 12C4, 12 choose 4. In the numerator, I'm going to select the 4, but only from these 9. Right? So it's 9 choose 4. So the numerator is because I'm selecting 9 items from the 4 that are non-defective. So that's what the question is asking. And then the denominator, I'm selecting 4 from the total. So to find this number, I'm going to use the calculator class calc, as what I've been using in our videos. So here's what the website looks like. And here, let me move my bubble to the side so we can see this. Up here in the top corner, it has the graphing calculator. I really don't need the graphing. I can do this problem on the scientific calculator. So it could be this environment. Later on, for more complex problems, for more specific problems, statistics, I'm going to use the menu for the graphing part. But it's just a little bit more, it's a smaller menu here. So the NCR are hidden here. If you click at the stat button, you have the NCR here. So if I click the NCR, what opens is the command NCR and then a parentheses to put the 2 variables. I needed to find 9C4, so you type it like this, and it gives you right there the answer is 126. I needed to divide this by 12C4. So the cool thing about having it here in this calculator is that I can just type here the division button. You can use a keyboard or use the button here in the calculator. And it writes it exactly, it displays it like I have it written in my, exactly what I had written here. That's what you see, right? 9C4 divided by, and I'm going to write 12C4 in the bottom. Now I got to the NC4 by going to the stat, and it shows up here. But if you want to, if you're that will works always if you're also in the app, because this calculator also has the app to do it, download on your phone or your tablet. But in the computer, you could also just type NCR. Sorry, it's uppercase. It doesn't matter, I think you put upper lowercase. If you type NCR, once you complete the 3 letters, it understands the command you want, and I wanted the 12 4. So it already has the comma there. Just be careful that you don't have to type it. Just scroll with the arrow to the right and put the 4. So it's 25%. So it's 0.254545. So I'm going to write my answer here. Okay, so my second question said, find the probability of selecting 1 defective. So now I'm going to do a little simple. The denominator doesn't change. The denominator is exactly the same, right? I'm dividing 12C4, but then my numerator is I'm selecting 1 defective. Now I'm still getting a total of 4. So those 4 means I'm going to get 1 defective and 3 from here, right? So that's a little setup that I like to write. So then that means I'm getting 1 from the 3 So I can write that down like 3C1. I know what that answer is. 3C1 is a 3, right? How many ways can you select one from 3 possibles? You selected one of the 3 there, so it's 3C1 is just a 3, but I'm going to write it down for completeness. And then I still need to select 3 more resistors, which are going to be picking from the 9, right? So that's going to be 9C3, and you multiply them. You're multiplying them because we're using that fundamental principle of counting, and when you want to know 2 things in a row, you multiply them. So it's 3C1 times 9C3 divided by 12C4. Okay. So let me write that in my calculator. I can, again, type that directly here. I can just edit this one. So I can do NC3, and I need to add a 3. I said that number was a 3, so I can just put a 3 here and multiply it. Right, if you multiply or not, it's going to get the same thing. But if you, in case you want to type it exactly as it is, you can write NCR. Oh, that didn't work, sorry. So I'm going to be careful and put it afterwards. Put the times first, because I think it wanted to embed one nested NCR in another one, so just be careful when you type that. So it's better to do from left to right and not. And then you put the, I'm using 3C1. Right, so that's the answer I had when I multiplied by 3. So it's 5090909, 0.509, and I'm using 4 decimals, so 0.901. Okay, so I wrote it like this. Okay, and for the last one, it's very similar. Now I want to find 3 defective resistors. So now it's a little bit, I don't know if backwards, but I want to find 3 from here and 1 from there, right? The total is still 4. So when I find 3 defective resistors, there were only 3. So there's only one way to do that. There's only, you can select all 3 from that pot. So I'm going to do, I'm going to write it, like I said, just for completeness, that's going to be a 3C3, right? That's a 1, right? 3C3 is 1. There's 3, how many ways can you select 3 objects from a group of 3 objects? There's only one way. You selected them all, right? But I'm going to write it down just for completeness, but that is a 1. And then I'm selecting only one object from the other 9 to complete my 4. So it's 9C1. And this number, this numerator, I know that these combinations sometimes we have like no intuition of what the values are, but the NC1 is always N, right? So 9C1 is how many ways can you select one object from a group of 9. There's 9 ways, right? You select the first or the second or the third or the 9th one. So that's 9. So all my numerator there is really just a 9, right? Because this term is a 1, this term is a 9. But I just wrote to complete the logic of how you would do this. Okay, so now this would be 9. Let me go to my calculator. There. And I can divide all this. I can put a N33 if you want. And this was NC1, like that, and it's 0. I want to show you that if I just had a 9 in the numerator, it's the same answer. So let me put an enter here and get a new line of commands, and I can write 9 divided by NCR of 12, which is 4. Yeah, so that's exactly what I had before. So the numerator is just a 9. So it's 0.01. 0.18. And I'm doing 2 decimals. So if you do 2 decimals, it will 0.0182, correct? Do 4 decimals. So that would be my answer here. Okay, so this is my examples for this. There are several problems that typical problems in textbooks that look exactly like this. And after you do a few of them, you get a hold of how they work.